in recent times how earthquakes have shaped the course of human history. On March 11, 2011, Japan experienced its largest ever earthquake, and the fourth largest anywhere in the world since records began in 1900. A megaquake, it struck below the Pacific Ocean, about 80 miles east of Tohoku's largest city, Sendai. It arrived with a staggering magnitude of between 9.0 and 9.1. The force of such a massive earthquake generated an enormous tsunami with waves more than 130 feet high. It also caused the infamous Fukushima nuclear disaster. The results were devastating. More than 19,000 people died. More than 450,000 were left homeless. There was an estimated cost of over $220 billion in damage, and much of the immediate surrounding area is still uninhabitable due to toxic material released during the meltdown. The quake and tsunami caused damage worldwide too, including millions of dollars worth in Hawaii and along the coast of California. It currently stands as the most expensive natural disaster in history, with the effects, particularly of radiation, still being felt today. And all of this unfolded in what's generally considered to be the most earthquake-prepared country on the planet, in Japan. So what is a megaquake? Currently, there's no clear consensus, but they can generally be defined as an earthquake ranking at 9 or higher on the moment magnitude scale, although they can be lower. This scale is the measuring system now preferred by most seismologists, rather than the traditional Richter scale, as it more closely charts an earthquake's energy, to the power it produces. Since 1900, every single recorded megaquake has also been what's known as a megathrust, with megathrusts occurring specifically in subduction zones, which are areas of the world map where one tectonic plate is sliding under another. But what could all of this have to do with the west coast of America? While many are familiar with the famous San Andreas fault line cutting through California, and with good reason, it's actually not, by some counts, what the west coast should be most concerned about. San Andreas is a strike-slip fault line, which means the tectonic plates that meet there are moving sideways against each other. As such, it's thought that it can only produce an earthquake with a maximum magnitude of about 8.1. Damaging for sure, and certainly with the potential to be life-threatening, but far from being as large as the earthquake that devastated Japan. It's thought that the greater danger then lies further north up the American coast and into Canada at the Cascadia subduction zone. Here, we have a 620-mile fault line that stretches from northern California to southern British Columbia. Tectonic plates are moving above and below each other, and in this region, megaquakes are a question not of if, but of when. The last megaquake to hit the Cascadia zone occurred on January 26th in the year 1700. We can't be totally sure for an event that far back, but it's believed it had a magnitude of around 9.0. It caused extensive damage on land and produced a tsunami that swept across the Pacific Ocean. The geological record shows how coastal forests and marshlands were submerged, but also, significantly, that this wasn't a one-off event. Megaquakes in this region have historically proven a regular occurrence. It's thought at least 13 of them have hit within the last 6,000 years. And while the gaps between megaquakes have ranged from relatively long to relatively short periods, on average, the Cascadia zone has seen one every 500 to 550 years. It's now 320 years since the last one. But according to geophysicist at the University of Washington, Aaron Wirth, we have a 14% chance of a magnitude 9 hitting the region in the next 50 years. Whenever the quake does hit, it'll impact roughly 60,000 square miles of the US and Canada, including the cities of Seattle, Portland, and Vancouver. Various estimates claim that a quake could kill more than 10,000 people and leave more than 1 million people homeless. But those numbers could also be a conservative prediction. By all accounts, this would be an intense, high-level disaster. So how would it play out on the ground? What are the stages of a disaster this massive? What are known as P waves would come first. These are fast-moving, high-frequency waves and are inaudible to humans. But dogs and other animals can hear them and may respond. While strange, P waves double up as last-minute warnings, as they typically arrive around 60 seconds before the actual earthquake erupts. Once they're felt, sensor-driven early warning systems can kick in to prevent damage and save lives, triggering automated tasks such as the immediate shutting down of railways, as well as the sending out of instant alerts to the public. For decades, there was very little by way of an early warning system in place along the West Coast. But thankfully, they do now exist. Most notably, the Shake Alert system, which was expanded in 2021. Now, if the first signs of a megaquake were to be felt, millions of local people should be warned to take cover. After P waves would come surface waves, which are what cause most of the visible damage, tearing the ground to pieces. Here's when things like the power grid fails, windows shatter, and shelves come crashing down. More significantly, though, the very foundations of homes and buildings can loosen and become detached so that they travel with the earthquake. This would see houses sliding off their bases and tower blocks crumbling to the ground. In the worst-case, most widespread scenarios, millions of homes would be under threat. Landslides would be triggered, turning the rest of the ground into an unstable slushiness. But the situation is only going to get worse. There could be as little as 10 minutes between the initial earthquake and the resulting tsunami. The window to escape the third and final wave is extremely small, especially considering that so many of the roads out of the area will likely have been destroyed. For perspective, the 2011 tsunami that hit Japan rocketed out of its epicenter at 500 miles per hour. At that speed, the entire ocean rises up with waves up to 5 stories tall. As it hits the shore, it levels anything in its path, causing damage so widespread that the extent of it would be visible from space. And finally, the aftermath would be almost apocalyptic. Search and rescue operations would unfold in the first few weeks, followed by a massive national and international effort to restore some sort of infrastructure. The hazards would be too many to count, though. Buildings and cities would be deemed structurally unsound for months, if not years. Power stations could create severely toxic environments, as we unfortunately saw in Japan in 2011. And the emotional strain could take generations to recover from. Parts of the West Coast rank amongst the most populated in the whole of North America. There are iconic cities, cultural hotspots, and instantly recognizable locations, but they could all be lost. For now, it's a race against time. The true nature of the Cascadia subduction zone was only discovered in the late 20th century. Before then, the region was believed to be relatively safe from earthquakes. We now know that it isn't. That in fact, it could one day become the site of one of the largest earthquakes in history. The good news, however slim, is that the surrounding area has started to strengthen its building codes to better earthquake-ready its infrastructure and to implement evacuation plans. The recent developments of an early warning system could prove vital as well. There's still work that needs to be done in a region that until recently didn't realize that it was under threat. But preparations are being made. And it's no wonder, because that's what would happen if a megaquake were to strike the west coast of the United States.